So let's begin with a familiar problem. We have three people, Michael, Quincy, and Sonia. They're scheduled for job interviews at GameStop. So how many different orders can they be interviewed? So, for example, we could interview Michael, then Quincy, then Sonia, right? Or we could do Michael and then Sonia and then Quincy. Or we could do Quincy, Michael, Sonia. You get the idea? And that's how many possible ways we could decide on our interview process, right? We have to, once we interview a person, we're not going to interview them again. We have to go through everybody first before we go do that again. So these are all the possible orders, right? There's a total of 6 of them. Now we've established that mathematics is really convenient because it can help us figure this out without having to write them all out. So how many options for the first interview? Well, I have Michael, Quincy, or Sonia. That's 3. And if I were to interview one of them, that leaves 2 of them. And then that'll leave one more person at the end. And of course, if we multiply this out, that's a 6 for the answer, which we already know because we actually listed all the possible ways we could interview the 3. So what if there were 5 people to interview? Well, we would have to interview all of them. So that's 5, and then 4, and then 3, and then 2, and then 1. And that ends up being 120. Possible ways to interview 5 candidates. Now, there's a smarter and sharper way to write this out. And you'll notice that we are pretty much each time we're multiplying by 1 less until we get to the last one. This is called a factorial. A factorial is an exclamation mark. So for example, if I have, like if we have 3 factorial, that means 3 times 2 times 1. Or in this case, if we have 5 factorial, that is 5 times 4, 3, 2, 1. This is convenient because let's say we have a deck of 52 cards, right? And I want to see how many ways I can order or arrange all 52 cards if I pick them all. Well, that would be, I have to make 52 little spaces, right? And then I have to put 52, 51 each time I pick a card, right? All the way down to the last one. So instead of me writing all that out, I could just write 52 factorial, because that implies 52 times 51 times 50 times 3 times 2 times 1, right? And everything in between. So instead of me having to write them all out, I could just simply say 52 factorial. Now, by definition, 0 factorial is going to be equal to 1. Okay, so if you see 0 factorial anywhere, that's going to be equal to 1. So what do these look like? Let's start with problem 2, and we'll look at part A. And the math is actually enjoyable. So 5 factorial means 5 times 4 times 3 times 2 times 1. And if you multiply that all out in a calculator, you get 120. So, we've been doing adding and multiplying for the last few videos, and that's pretty much what we are sticking to. 3 factorial times 3 factorial. So 3 factorial is 3 times 2 times 1. And the other 3 factorial is 3 times 2 times 1. And if I go ahead and multiply all that out, that's 6 times 6, which is 36. Now, I'm not interested in the answers as much as I am in the setups and the processes. Okay, so just be aware. Notice that this only has 1 factorial. And when I say factorial, that's the exclamation mark. So it only applies to just 3. So that 3 in there is 3 times 2 times 1. But there's a 3 on the outside. So it's going to be 18 when I multiply that all out. 3 times 3 is 9, times 2 is 18. This one here, 2 factorial is 2 times 1. What's 5 minus 3? Remember, we do order of operations, so we do the inside first. 5 minus 3 is 2. Right? So this whole thing is 2 factorial. And there's a factorial on the outside. So that makes this 2 times 1. E, we have 5, 4, 3, 2, 1. And then on the bottom, what's 7 minus 3? It's 4. So I got to write out 4 factorial on the bottom. Now, get ready to just really enjoy this. Look at this. 4, 3, 2, 1. The answer is 5. Can we do that? Yes, we just did that. Okay. So with factorials, the convenient thing about this is we can simplify things very quickly. And the idea behind this is that the numbers on the bottom are representing things that are repeating. More about that in a bit. F. So your setup should look something like this, right? The 3 factorial is here, and then the 5 factorial is here. You'll note that the 5, 4, 3, 2, 1s cancel out. And at this point, if you want to put it into the calculator, you can. You're going to get that the answer is 56. For those of you that are very much more capable, notice that what's 3 times 2? It's 6. And there's a 6 up here. So this can cancel this out. 8 times 7 is 56. Over 1, which is 56. Can we do that? Yeah, I just did. This last one, 6, 5, 4, 3, 2, 1, because 6 factorial. 3 factorial is 3, 2, 1. And 6 minus 3, that's 3. But there's factorial on the outside. So that's going to be another 3, 2, 1. And of course, these cancel out. And if you want to do a little trick again, 3 times 2 is 6. 5 times 4 is 20. Folks, we are just doing addition and multiplication. So, yeah, you got this. For your summary, rewrite problem 1, parts A and B using factorials.